You asked and we're answering. Whether you attended one of our PADS professional DDR webinar events live or watched the recording on demand, a lot of great questions were asked, so let's get the answers. Hi there, I'm John McMillan, and welcome to the 9th podcast in this special series of PCB Tech Talks, the After the Webinar series. In this special podcast series, I'm joined by webinar presenters as they answer and discuss the questions submitted by attendees during our recent DDR webinar. As always, be sure to subscribe to this podcast and let us know the topics you'd like to discuss and if you'd like to be our guest right here on PCB Tech Talk. Today, I'm joined by the DDR webinar demo presenter, Rebecca Lord. So hi, Rebecca, and welcome back to PCB Tech Talk.
Hi, thanks, John.
How things been going?
I'm pretty good. How about you?
I'm really good. So Rebecca and I were just out at PCB West a few weeks ago, and you want to talk a little bit about what you presented out there in the exhibition floor?
Yeah, absolutely. I was out there talking about our schematic validation tool and how it can help you save time in your design cycles.
Yeah, that's a very unique tool. I don't know if any other EDA product out there that actually has pre-layout schematic design rule checks. And it's a really great product, and it was you had a very well attended theater presentation. So
yeah, I even had a customer that told me that their company had had a demo done on one of their designs, ended up finding a pretty fatal flaw, even though manufacturing had already started. And so they had to halt manufacturing after they found that issue with the schematic validation tool.
Yeah, and then you're thinking with our new left shift processes that it's something that you can do pre-layout, and you can continue as you make changes throughout the design phases. As changes always happen in PCB design. You can continually go back and run schematic validation to ensure that your PCB does get fabbed, and hopefully catch it even before you get into layout. But you also, but it's a continual process of as you make changes, continue to do schematic validation, then move right into layout. So
definitely. Kind of along the same lines as, with our DDR webinar, you're able to do pre-layout simulation with that. It's not schematic validation, but, it's through that whole design process. You can do the pre-layout simulation and then find the initial parameters that you're going to be using for your layout itself, and then you can do simulation post-layout.
Absolutely. So let's dive into the DDR webinar questions. Again, these are the questions that we either addressed during the European and US sessions, and the ones we don't get to, we're also going to cover during this. I can jump in and take the first one, if that's okay.
Absolutely.
So the first one, what layer should DDR signals be routed on? And actually, the answer this was during the European session, and it's a very design-specific question. So what I can say about that is that you should aim to route all your DDR signals on ground reference layers. That's the general rule of thumb. This helps you receive the lowest possible impedance for return currents. The DDR signals, they typically require using several layers, and how much board real estate you use will be the proximity of the connected components and matching all those trace lengths. Also, following high-speed best practices like avoiding crossing split planes will also improve DDR signal integrity performance. So that was a very good question. Go ahead and take one, Rebecca.
Thanks, John. Can I simulate other DDR interfaces such as LPDDR using Hyperlink's DDR? The answer to that is yes. The DDRX wizard allows you to simulate LPDDR in addition to non-volatile DDR interfaces and then traditional DDR 2, 3, 4. Can I account for setup and hold derating values in my simulations? Yes, you can do this by adding your own user-defined derating thresholds or the JetX standard derating values into those timing models. You can do that with the timing wizard, or you can actually edit those files directly.
Before we get too much further, if anyone's listening to this podcast because they're a subscriber and they didn't actually attend the DDR webinar itself, it is available on demand. If you go to pads.com, you'll be able to see in the carousel a link to how you can get to the on-demand version. So you can watch the webinar and then you can follow it and understand where this Q&A came from and what these questions are all about. So with that said, I'll take the next one, which is DDR simulation related also. Is DDR simulation necessary? And it's a great question. Yes, and even more so with DDR4. Historically, prior to simulation, designers were subject to being over-engineered, and designers used like rules of thumbs or assumptions that worked for their previous designs. So they took into account the troubleshooting they succeeded with after probably spending a lot of money on respins. And then they figured out if it would work for the next. And companies actually built in additional project cost for prototypes to dial it in. So DDR simulation takes the guesswork out of designs. It enables you to design faster. It ensures performance. And as a result, because you don't have to do all those respins, it reduces cost and time, and that saves you money. So it's a great question. It is necessary, particularly with DDR4. We're just getting faster speeds out there, high speed, low voltage. That's how industry goes, right?
Yeah, that's a good point, John. Here's a good question that we had during the session. Why would you use VTT termination regulators for DDR3 and DDR4? So that's a good question. With DDR2 kind of introduced the on-die termination, especially on the DRAM modules. It's sort of dependent on whatever memory controller you're going to be using, that if they'll have ODT on there as well. But with DDR3 and DDR4, it would be pretty surprising to not have any sort of on-die termination. So you won't typically need to use VTT termination on the data nets, but that doesn't apply to the address nets. So you'd probably be using VTT termination on those address nets and not the data nets. Can you further explain the right leveling option that you mentioned? Yeah, so again, with DDR3, that's when they sort of adopted flyby topology for routing. And so with that, the clock signals use the flyby topology, but the strobe signals are actually still routed point to point. And because of that difference, that can create large skews between the clock and the strobe signals at the DRAM devices. So in order to account for that, the memory controllers add delays to the data byte lanes, and that allows the strobe and clock timing requirements to be met. So the right leveling option in the DDRX batch wizard actually calculates those skews that the memory would be implementing in real life, and then you can take that into account in your simulation.
Yeah, that's good information. So I'll take the next one. What about the board stack up for routing DDR? And this was kind of similar to the layers question. I'd have to know more about your design to give you the best answer. But I will say, as I mentioned earlier, ground plane referencing is critical for DDR routing. If trade-offs must be made, the general rule of thumb has been, to allow, data and clock signal groups to be routed over solid ground planes and DDR signal groups to be routed over solid power planes. So that's general rule of thumb, but a lot of it depends on, the density of your design, how much room you have to actually get your routing in with all the matched lengths and all that kind of stuff, whatever tuning you need to do. So, on the note on tuning and matching signal lengths, I want to emphasize, how our PCB layout technologies like sketch routing and tuning and multi-trace tuning are huge time savers that enable designers to drive DDR routing precision. And in turn, you get first pass design success, which also saves you time and cost. So once you have all the rules written in your signal integrity, you've got your topologies set. It makes routing the DDR signals and doing the tuning fast. So just want to point that out.
Yeah, absolutely.
So what I'll do is, in addition to supplying the link to the on-demand webinar for DDR, I'll also add some links in there where you can see the webinars we actually did on routing technologies a few months ago in the show notes.
Kind of along the same lines as your last question, John, about stack up, is how accurate are the hyperlinks impedances in the simulation, specifically the stack up information. And all of that is pretty accurate because it's just, it's the math. It's calculating all of those numbers, which would be pretty realistic to the real world values. And you're not going to have, the error. But in this situation, you're routing those traces on the inner layers. So it's going to be pretty accurate. The impedances are going to be very accurate, and you're not calculating things like propagation delay when you're thinking about error, but especially when you're routing on those inner layers, it's going to be pretty accurate. What are the differences between the ODT model selectors and why do they matter? So that's a good question. ODT selectors represent the different on-die termination values, And as you know, the on-die termination was implemented in DDR2, and it has been since then. And so sometimes those on-die termination values in DDR2 and above, they come into account when you're doing your simulation, because that will determine a lot of your signal integrity, and you can take that into account with these different ODT model selectors. And those are available on both the controller and the memory. So those values are specific to the components in your design because they're derived from the IBIS models that you have added for your specific components. And those values are really important for optimizing DDR interface signal quality. And with the pre-layout DDR wizard simulation, you can run sweeps, kind of like I did for the length. You can run sweeps for the ODT model selectors to find out which combination is going to work best for your design. If the vendor for my component provides me with routing guidelines for the DDR interface, why would I still need to run pre-layout simulation to determine those guidelines? That's a really good question. And some vendors do provide the layout guidelines for their DDR devices, but those guidelines are using predetermined parameters for things like the stack up and the board size and the termination scheme. So with the varying level of complexity in today's PCB designs, your product most likely doesn't follow those exact same parameters. And since the vendors are basing their guidelines on that, yours could be totally different. And performing the pre-layout analysis allows you to actually determine the routing specs for your specific board, taking all of those different values into account that are design dependent.
There was a question also submitted during this webinar about having a student edition. We have a fully functional PADS Professional Student Edition available. Well, not a lot of questions, Rebecca, but there was several good ones. The sessions were very well attended. So thanks for joining me, and it's great to have you back on PCB Tech Talk.
It's good to be here. Thanks, John.
Sure, and hopefully we'll be talking to you again soon.
Definitely.
Thanks, Rebecca, and thank you for joining me for this special After the Webinar series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There you'll also find additional information related to this podcast, along with my email address. So feel free to send me your comments and questions, or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, iHeartRadio, Stitcher, or your favorite podcast app, whatever that is, and be sure to catch the next episode of PCB Tech Talk.